Hello class. Today we'll be going over section 3.2, solving quadratic equations by graphing. As you should recall yesterday, we went over how to graph quadratic functions, and today we're going to be using that as a means to solving quadratic equations by graphing. So first we need to know what a quadratic equation is. So a quadratic equation is a quadratic function that is set equal to a value. So an example of this might be x squared minus 3x plus 6 equals 4. So as you can see here, we have a quadratic function, or a quadratic equation set equal to a value. Now, in order to really manipulate this and work with it easier, we want to set it in standard form. So standard form is ax squared plus bx plus c equals 0. So we want to get everything over to this side so that it's equal to 0. So we also want to make sure that when we have this quadratic function or this equation, we want a to not equal 0. And this is because if a is equal to 0, then it would cancel out this first term, the quadratic term. And then all that would be left is a linear term. So if we want to write this in standard form, we would take x squared minus 3x and subtract 4 from both sides. Minus 4 minus 4. And we get plus 2 equals 0. So that would be this quadratic equation in standard form. Now next we want to solve these quadratic equations. And the way we can solve quadratic equations is by finding the roots. The root of a quadratic equation is the solution to the equation. So the way we're going to find that is by finding the zeros of the equation. Now what this means is by finding a zero, we're going to find what x that we can put in here to have this equation equal 0. So here's an example of a quadratic function. F of x equals x squared plus x minus 12. Now here, as you can see, if we plug negative 4 into here, we get negative 4 squared plus a negative 4 minus 12, and that comes out to 0. Additionally, we have another root where x equals 3. You plug 3 in for x, and you get 0. Now, it might be challenging to see, like, how do we come up with this as an answer for the roots, but that will be a way that we can do that is through graphing the function. So if we graph this function right here, x squared plus x minus 12, we have the roots at negative 4 and positive 3. So the graph for this would look something like that. Again, I'm sorry I did not draw that very well. It would probably come down here a little deeper, but for the sake of space, we're drawing it so that it goes through negative 4 and 3. So as you can see from this, it crosses over the x-axis at negative 4 and 3. So that is where x equals, that's where the function is equal to 0. So you can see it through graphing. You can also find the zeros using a table. Now in this table, you have your inputs of x, and a root is where you're going to have an output of 0. So in this table, we have negative 3 is equal to 0. So that would be a root there because f of x is 0. And if you find 0 anywhere else, right here, excuse my my chicken scratch, I miswrote there and had to scribble it out. But here we see that where x equals 1, f of x is equal to 0 as well. Now, this is important to not get tripped up, as we see the input here for x is 0. So x is 0, but the root, this is not necessarily a root because the output is at -2. So these two are roots, but this one is not. So be careful, not just because x is 0 does not mean it is a root. We want the output, or the y value, to be 0. Now when we have when some quadratic equations can have no solution, some might have 1, and some might have 2. So I'm going to show you graphically what that looks like. So when a quadratic equation has no solutions, it might look something like this. See how on this graph it never touches the x-axis, so it never crosses, and so that means there's no roots. So here,
so an example of that.
Here we have one solution, and that would look something like this. If it came and touched just at one point. So it would come down, and at the vertex would be pointing at the point and touching the x-axis, so it would have one solution. And here, if we have two solutions, it might look something like this. So as you can see, it crosses twice across the x-axis. So we have two roots in this situation. Now here, we're not always going to be able to see exactly where the roots are. They're not always going to be integers and pretty for us. So we can estimate the roots graphically. So they don't always fall on integers. So we can find them to the nearest integer. Now here is an example of a graph where the roots don't fall on integers. So what we would do in this instance is we would say that one root falls between, where does it fall between? -1 and 0. Another falls between, where's this one? Between 3 and 4. So between 3 and 4. So based on this graph, again, it's not on a, the roots are not exactly falling on integers. So we would try to find the nearest integers that they are to, which is -1 and 0 for this one, and then 3 and 4 for that one. So we can, however, we might not be able to solve it by hand and find exactly where the root is, but we will be able to do this with a calculator and find exactly where the root of a function is if it doesn't land exactly on an integer. So what I want you to do is pull out your calculator, and I want you to graph the function f of x equals x squared plus 5x plus 5. As you can see, I have done it here already. And I want you to, if you want to pause your video so that you can type it in, go ahead. Okay, and now here we have, I'm going to show you exactly how to find the root exactly on your TI Inspire calculator. So first, you're going to hit menu. Then you're going to go down to where it says Analyze Graph. And then it'll pop up, it says 0. So you want to select 0. It's that first option right there. So now you're going to select a spot somewhere to the left of where it crosses the x-axis. So out here is fine. And then you're going to select a spot to the right of it. So it knows that it's capturing between those two bounds that you set. And here we have the answer of negative 3.618. And so that would be our answer. And I want you to round that answer to 3 decimal places. And I want you to now repeat that process on your own for this other root here. So again, hit menu, analyze graph, 0, select a spot on the left, hit enter, select a spot on the right and hit enter, and it'll give you your answer, and then round to 3 decimals. So pause the video right now and take another stab at it with that other root. Now, quadratic equations can also have other applications, especially in number theory. So we can use a quadratic equation to solve a problem like this. So it says find 2 real numbers with a sum of 15 and a product of 63. So this problem is from the book. And so we have 2 real numbers. Okay, so the first one we'll call x. The next one, x plus that number equal 15. So 15 minus x equals x. And so we'll just check out to make sure these 2 numbers equal 15. So just to double check, x plus 15 minus x, these cancel, so that equals 15. So yep, these 2 will get us a sum of 15. And their product will equal 63. So what we want to do now is get this into standard form. So we'll distribute the x. So we have 15x minus x squared. And we're going to subtract that 63 over. So we have minus 63 equals 0. So now, if we want to write it in standard form, we're just going to move this to the front. Negative x squared plus 15x minus 63 equals 0. So now if you want to plug that into your calculator, you can go ahead. I'm going to draw a rough sketch of it, and here's what it looks like. So if you see on this graph, it never crosses over the x-axis. So that would be an instance where we have no solutions. So since there's no roots, there's no solutions to this problem. So there are no solutions to this problem. So some problems are going to be like that. There's not always going to be an answer to a problem like this. So we're going to do one last example of a problem exactly similar, and we're going to see if this one does have answers. So find 2 real numbers with a sum of 13 and a product of 42. So similarly, we're going to call the first number x, and so the sum of them is 13. So we're going to have 13 minus x. And again, we're just going to double check here on the side, x plus 13 minus x. Well, the x's cancel out there, right? So we have 13. So that would be 13. So perfect. They add up to 13. And I have a product of 42. So again, we're going to try to get this into standard form. So 13x minus x squared equals 42. We're going to rewrite it in standard form. Negative x squared plus 13x minus 42 equals 0. And that's just what we wanted, is to have it in standard form. So now we can plug it in our calculator. I'll plug it in this time with you guys. So again, we have negative x squared plus 13x minus 42. If you look at that, it crosses over twice. And now what I want you guys to do is, again, use the calculator to find exactly where those roots are. And you can pause your video, and I'll let you do that. Okay, now that we've resumed the video, again, this is what the graph looks like. And as you found from using your calculator, you know that this is 6 and this is at 7. So the solutions for our problem are 6 is root and 7 are roots. So again, let's just double check to make sure that 6 and 7 would satisfy this. So 6 plus 7 equals 13, right? Yep, so that checks out. And then lastly, we need 6 times 7 to equal, what's 6 times 7? 42, and it checks out. Perfect. So 6 and 7 would be solutions to this problem. So now I want you guys to go ahead and start on the homework, and let me know if you have any questions on the assignment, and I'll be floating around.